Hello, good day. My name is E and I'm a representative of I.F.Mathematics.Academy, IFMA. And today we are going to be talking about differential calculus, and under this we are also applying the first principle. Now, to see further examples on solving first principle, solving equations using the first principle, please go to our previous videos and you will see the link to our previous videos down in our description. Now today our example will be y equals 5x minus 1 over x squared. Now, as I said earlier in our last video, we are going to add the change in x, to both sides. Therefore we have added the change to both sides of the equation. Now the change in y here and the change in x to this side. So now we are going to make the delta y the subject of the formula. So therefore we have and now we know that y equals 5x minus 1 over x squared. So therefore we can erase this y and input 5x minus 1 over x squared. So now we have imputed the value for y as 5x minus 1 over x squared. So now we expand our equation. So now we have expanded our equation, and therefore if we look at this critically as mathematicians, we therefore see that 5x cancels out 5x. So we can cancel out, and after looking we can find no other similarities in this equation, so therefore we write it as after cancelling out, this is what we get. So now we find the least common multiple. So after finding the least common multiple, we should have LCM of this equation, and it gave us this. And from here, what can we see? We can see that x squared can cancel out x. X squared can cancel out minus x. So therefore, and we look again. Do we see any other similarities? No, we don't. So therefore, we rewrite the equation because this already looks rough. So we have to rewrite it. And we have so now you can see no other similarity. So what do? We divide both sides by the change in x, as I said earlier in our previous video. So now after dividing both sides, after dividing both sides of the equation by the change in x, we have y, because this leaves 1. 1 multiplied by 5 is 5. How did we get this? Because we divided this by this. That's how we got this. So now we take the limits of both sides of the equation. That will be now, what does this mean? This means as the change in x tends towards 0. So there's a point where change in x is going to meet 0. So when that happens, change in x becomes 0. So therefore we have we then have change in x equals 0, which is also now we have turned change in x here to 0, which gives us this. So after taking our limits, we can then find out that our dy dx equals sorry, there's an error. I missed 5, so it's going to be 5 plus 2x. Therefore, so this then becomes our dy dx. And if you want to further simplify this, we can just take the least common multiple of this and find the answer. That's going to be a little more complicated, but we are going to leave it as this. You can expand, you can simplify this much further if you want. And so this comes to the end of our differential calculus application of this example, which is 5x minus 1 over x squared. And remember, the first thing we did, we took the limit of both sides of the equation. We took the change in y, of both sides of the equation, and we added it to both sides, and we did all that divided by the change in x here. After divided by the change in x, we took the limit of both sides of the equation, and therefore we established that change in x tends towards 0 and it becomes 0. And then we got our dy dx as 5 plus 2x over x raised to the power 4. So for more videos by I.F.MA, I.F.Mathematics.Academy, you can follow us on Twitter, YouTube, Facebook, and Instagram. We upload videos weekly, and share among your friends, especially those that need and love mathematics, as we all do here. And we say goodbye. Thank you.